So here at the top of the page are just some notes on when triangles are congruent, if you can do a sequence of rigid transformations. And then once you have proved that two triangles are congruent, then you have also proved that all their corresponding parts are congruent. So these are the 5 triangle congruency theorems that we discussed quickly on Friday. Side, 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 angle, angle, side, angle, angle, side, and hypotenuse leg. At the bottom, there are some common vocabulary words. These are words that are going to be used in proofs to help us state things that are true or congruent in order to prove that two triangles are congruent. Now, 2 that I want you to focus on for today are the reflexive property, when something is congruent to itself, and the corresponding parts of congruent triangles are congruent, also known as the abbreviation CPCTC. And that is after you've proved two triangles are congruent, then, like I said earlier, all their corresponding parts are congruent. I've had kids in the past think that CPCTC can prove two triangles are congruent, but the only things that can prove that two triangles are congruent are your 5 triangle congruency theorems. CPCTC can be used after two triangles are congruent. So go ahead and pause the video, find example 1, read over it, and then we're going to do example 1 together. In example 1, you're given 2 statements as well as what you need to prove. Anytime you are doing a triangle congruency proof, you need to mark your diagram. Whatever information they give you, the diagram needs to be marked with that information. You have 3 ovals on top with 3 lines below them. You put your thing that you're going to make a statement about in the bubbles, and then the justification goes on the line below. There are 3 bubbles here, which means that you're going to use a 3 something to prove these triangles are congruent. So you're going to use side, 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 angle, side, angle, so on and so forth. 3 bubbles means those 3 statements, and then the bubble at the bottom is going to be the triangles are congruent, which is what you need to prove, and then you're going to use your triangle congruency theorem underneath. So let's go ahead and get started. This first one says FG is congruent to HG. So FG is congruent to HG. And so I put a single dash marking that both sides are congruent. The next one says EG is congruent to IG, but it's not necessarily congruent to these other 2 sides. So I put a double dash and a double dash here. I need to prove that triangle FEG is congruent to triangle HIG. Order matters, so FG is not congruent to IG, so we need to, that's why the order matters, F to E to G, H to I to G. So we need something else. We have a side and a side. So I can't assume this side is congruent to side, side, side. I don't have 2 angles, I already have 2 sides. So if I flip back to the previous page, if I have 2 sides, I can use side, angle, side as long as the angle is included between those 2 sides. So let's find the included angle. The included angle has G in the center, but you can't say angle G because G has 4 angles. It has one up top, one down below, one on the left, and one on the right. So you need to make sure that you talk about the angle in between and the angle in between because that's the included side. Now hopefully you notice that angle FGE and angle IGH are vertical to each other, and we've already proved that vertical angles are congruent. So I have side, angle, side. I'm ready to start my proof. So in the first bubble here, and I'm going to use a ruler to make sure my things get nice and neat. You don't have to. But FG is congruent to HG. So that's a given statement, so I write given on my line. All right, that's my side. I now have an angle, so I'm going to say angle in order matters. So we're going to write FGE is congruent to, so I'm talking about this angle right here. And it doesn't matter if you start with HGI or IGH because we're just naming an angle. but I always like to practice the order mattering the way that we want to here. So if I said FGE, I want to say HGI, and those angles are congruent because they are vertical angles. And last chapter we proved that vertical angles are congruent. If you don't remember, go back in your notes. All right, so that's my angle. So I have one more side that I need to prove, and that would be that EG is congruent to IG, and that is also a given statement because it says that there at the beginning of the proof. So I have now side, angle, side. So now I said the two triangles are congruent. Remember, order matters. All right, triangle. And I can just look at it from here. So F, E, G is congruent to triangle H, I, G. F to E to G, H to I to G. So because EG was congruent to IG. So my triangles are congruent, and how do I know that? From side, angle, side, triangle congruencies. Boom. Oops, sorry. So I have just proved that the two triangles are congruent using side, angle, side. Please pause the video and try example 2 on your own. I will not be going over how to do example 2, so you need to do example 2 on your own. When you're ready and after you're done with example 2, hit play and I will be going over example 3. All right, example 3. I'm not going to go over example 2, so if you're looking here for an answer, you have to have example 2 done. That's why I asked you to do it. I'm moving on to example 3, so if you didn't do example 2 and you're just moving on to example 3, please know that example 2 needs to be done. All right, so I have, again, two sides that are congruent. So if I have two sides that are congruent, I'm either going to use an angle or another side. So let's mark it. AB is congruent to AC. AB is congruent to AC. BY is congruent to CY. But they're not congruent to the first side, so I put it in my double take. So I have side, 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 side. Side angle is not a proof because that spells a bad word. I can't tell if B and C are congruent. Yes, they may look congruent, but we have to prove it. And there's no way I can prove that B and C are congruent angles. So I'm kind of at a loss here with using an angle, so I'm going to look for a third side. So this third side is shared between the two triangles. And so AY is part of the first triangle and AY is part of the second triangle. So I'm going to say that AY is congruent to itself. Now remember, at the beginning I said that there was a common vocabulary word that says that something is congruent to itself. So hopefully you read over it, and if you didn't, take the time and go read that common vocabulary. I'm ready for my proof now. All right, so I'm going to start with my first statement. AB is congruent to AC, and I know that because it was given. And the second one, BY is congruent to CY. Again, that was given. I don't know why I wrote in all caps in that last one except for the letter N. And yes, that's going to bother me, so I'm going to fix it. Taking my time so you guys can copy the rest of the stuff down like I would if you were in class, and I was in class. All right. Ooh. Miss Gapor, move your hand out of the way. I will. Just a second. All right, so I have a side. I have a side, and we had a third side, and that third side is that AY is congruent to AY. Hopefully you read over the common vocabulary that I asked you to read over, and you know why AY is congruent to AY. If not, please go read it. You're not going to, you're just going to keep playing it, and it's the reflexive property. The reflexive property says that an angle aside is congruent to itself. So the reflexive property is when something is congruent to itself. So I have proved side, side, side. The two triangles are congruent. Again, I could steal it from up here, but yes, order matters. It matters, it matters, it matters. Will you get marked wrong? Yes, you will. BYA is congruent to triangle CYA. And I have to check. So like here, BY are the first two letters, and CY are the first two letters, and BY is congruent to CY. And then AB is congruent to AC, and AY is congruent to AY. Yeah, so my order is correct. And how do I know that they're congruent? From the side, 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 triangle congruency. And it is important to write that at the end because in this chapter we're going to be doing similar triangles, and some of these theorems are different between congruence and similarity. All right, please try example number 4. Hopefully you try it before you move on to example number 5. It will need to be completed before we turn in this packet. So I'm going to pause the video and go to example 5.